This video demonstrates the tools available in PowerFactory for carrying out arc flash calculations using the industrial network example. Study case 3 should be activated. For arc flash analysis, the network elements first have to be populated with all the required data. Let's look at one of the bus bars in the network as an example. On the arc flash analysis page, we see that the attribute Accessible Location is selected and that the relevant data items have been entered. The arc flash command is found here. The analysis will run short-circuit calculations as specified in this command. The arc flash calculation method has been selected. And with this option, a report will be automatically generated. On the Advanced Options page, we can see the input parameters such as the PPE categories according to the calculated incident energy levels. Back on the Basic Options page, there's an option to specify the arc duration using fixed times or according to the relay tripping times. To start with, we'll use a fixed time of 0.1 seconds. The command is executed and the report generated. Sorting by PPE category, we see that there are no major problems. Results can also be viewed on the graphic or in the Network Model Manager. For a more realistic calculation, let's now select the option to use the relay tripping times for the arc duration and run the calculation again. Now we can see that there are some bus bars where PPE category 3 or 4 is required and some where the incident energy is too high for the available categories of PPE. Note that it's also possible to run the arc flash calculation for a single bus bar. We'll do this for bus bar 3 as an example. For this bus bar, arc flash analysis has determined a fault clearing time of 0.92 seconds and a PPE category of 3. One way of improving this situation is to reduce the fault clearing time. Let's look at the time overcurrent plot for this bus bar. We can see the characteristics of the relays around the bus bar, including the bus bar protection relays with their fault clearing times of 0.92 seconds. We'll now run a short circuit calculation for line CE1. The downstream relay on the line has a fault clearing time of 0.755 seconds and the upstream relay has a fault clearing time of 0.92 seconds in order to achieve selectivity. The fact that a fault on the bus bar will only be cleared after 0.92 seconds means that there will be high incident energy in this case. We therefore need to find a way to accelerate the tripping time for a bus bar fault without losing selectivity with the downstream relays for line faults. We'll introduce a third instantaneous overcurrent protection level in the upstream relays, controlled by an interlocking scheme. This will have an additional relay for the purpose of signal comparison. If we change the study case time, the relevant expansion stage is activated and the interlocking relays are introduced. Now, if a short-circuit fault calculation is executed on line CE1, all the relays will act as before. But if the short-circuit fault is on the bus bar, the outcome is different. The upstream relays will trip as fast as possible. In the case of a line fault, the new relay generates a blocking signal to prevent this fast tripping of the upstream relays. Let's look at how this works. The interlocking relay makes use of two DSL models: a send adapter and a receive adapter. The logic is as follows. These are the relays involved. A starting signal which indicates whether there's a local downstream fault is sent sequentially from each line relay to the next, where it's then evaluated and sent onward to the next relay down the chain, then finally onto the relay at the busbar switch. The signal is received by each of the upstream relays. If there has been a line fault, the fast tripping of the upstream relays is blocked. So now we'll run the arc flash calculation for busbar 3 again. We can see that the PPE category is now determined as 1 as the incident energy is lower. The arc flash reports command, which is used to create the tabular report of results, also has an option to generate arc flash labels. So let's run the calculation for all locations again and see how to generate the labels. This icon can be used to generate the tabular report that we've already seen. But there's another reporting option that can be used to create arc flash labels. By default, these labels are created in PDF format and viewed using the inbuilt PDF viewer. These icons can be used to export or print the document. If the labels are required in another format, such as Microsoft Word, this can be done by using the generic report command. First, the arc flash label report is selected. On the export page, the location and format for the exported documents is selected, then the command executed in order to export the document.